Let's ask then, if carbon reactive species wanted to combine with each other, what would happen? Well, let's look at H3C dot. Remember, that was 7 electrons. It needs one more to share. If it's shared with hydrogen, it would give you methane. If it's shared with another CH3, it would give you ethane. H3C, CH3. Both carbons then would have 8 electrons in the outer shell. There would be a single bond between them. If CH2 combined with another CH2, that would give you H2C, CH2. There are 4 electrons being shared. That's 2 bonds. We draw a double bond there. And if HC combined with HC, or CH, then that would give you HC, 6 electrons being shared, that's 3 bonds, CH, ethyne. Let's mix up carbon and nitrogen. If we have H3C dot, that's 7 electrons, remember? It needs 1 electron to make 8. NH2 dot also needs 1 electron. Happiness. If they bind together, H3C, single bond, that's 2 electrons being shared. NH2, that's actually methylamine. What about CH2? Well, it's 6 electrons. It needs something that also wants to share 2 to get a stable octet. That could be NH. It's also 6 electrons. So when you put these together, there are 4 electrons being shared. The carbon then has 8 electrons. The nitrogen then has 8 electrons. And we get actually an imine with a double bond between the C and the N. If a CH wants to complete its octet with a nitrogen species, it could just use nitrogen. CH has 5 electrons, it needs 3 more. Nitrogen has 5 electrons, it needs 3 more. So put them together, they share 6 electrons, giving 3 bonds. Then the carbon has 8 electrons and the nitrogen has 8 electrons. Let's play the same game with oxygen. If we combine H3C, 7 electrons, with OH dot, well, that's 6 electrons in the outer shell from the oxygen, 1 from the H. That's 7 as well. Combine them together, they share 1 electron each. 2 electrons being shared is a single bond. We've made methanol. CH2 is looking to share with something that also wants to share 2 electrons, and that would be oxygen. So 6 electrons from the carbon and the 6 electrons from the oxygen, they combine and they give you CH2O, methanol, formaldehyde. Let's screw up. Let's try to combine HC, 5 electrons, with oxygen that has 6. Well, if we put them together, well, we'd only have 7 electrons on the carbon because we only shared the 2 that the oxygen needs to share. So we have to call that HC dot and then a double bond to the oxygen. The carbon's not happy. That's not stable. So you see the big point here. If you understand the electronic configuration, you understand the shapes of the Lego bricks of chemistry. And if you can master that concept, you can play Lego with fragments that are useful to combine in actually an infinite number of organic molecules. You see what a powerful concept that is? It's something you definitely have to know before you go on. Students learn organic chemistry by remembering some key facts, learning pivotal concepts, then applying the concepts in problems until the concepts are mastered. To help with that, I'm preparing an eBook on hybridization and bonding to be published on iBooks for the Mac and Amazon Kindle. The 4 workbooks, Sophomore Organic Chemistry by Inquisition, are available from Amazon and from the byinquisition.org website, where the answers can also be found. Thanks for listening. Bye.